The second section of this chapter deals with precipitation and qualitative analysis. What is a precipitation reaction? You probably already know that precipitation is the formation of solid products. When you mix two solutions made up of ions, you are going to sometimes form a solid, especially when we're talking about solubility product. These are substances for which the substances often form a solid under standard conditions. So we have done questions like these in intro. And you notice here it says, when the value of Q is greater than the KSP, precipitation occurs and will continue until the concentrations are reduced to the point where they satisfy the KSP. If Q is less than the KSP, no precipitation occurs. I will do an example of one of these questions in a minute, but I'm going to follow along this PowerPoint and you can see the kinds of questions that are going to be important from this. Sometimes you have to answer questions, which we'll do at the end. Now, why am I showing you all of this? Well, you can see that in your textbook and here on this particular slide, they're showing you how you separate copper ions, mercury ions, nickel ions, and manganese ions using H2S. Essentially, what they're showing you is that if you have a solution of one of those, perhaps you don't know what solution you have, and you add some H2S, what will happen is copper sulfide and silver sulfide will be produced, and you'll be left with a solution of manganese and nickel. So obviously, if you have no idea the identity of something, and you add some H2S, and you know it's one of those four solutions, you can kind of reduce the pool of potential solutions. If a precipitate forms, it must have been the copper ion or the mercury ion. If it doesn't form, meaning it still stays in solution and no precipitate is visible, you're going to have a solution of manganese and nickel. And you can see if you add OH to bring it to a pH of 8, you can eventually get a precipitate of manganese sulfide or nickel sulfide. So the idea is, through a series of additions of different substances, you can figure out the solution. Here is a huge chart that shows some interesting separation techniques that are pretty common by precipitation. I will not read this to you because you can read it in the book, but the most important thing that you want to take away from this chart, and they actually give you a little bit of a write-up in your textbook on page 757, is the 12 mystery test tube experiment that we're going to do in a future class. What I will be doing is I will be giving you 12 solutions. Each person is going to get, we're all going to get the same 12, but they're all going to be numbered differently. So one person's unknown solution number 1 is not going to be the same as another person's unknown solution number 1. So you'll be given 12 unknown solutions, and your job will be, through a series of mixing, to essentially precipitate certain things out so that you have the ability to predict what the unknown solutions are. Part of what I'm going to be asking you to do is to do a little bit of research on how you plan to do that. So when you get the ions, you can perhaps use charts like this one, or other ones you can find online or in the textbook to help you figure out your procedure. And the goal of that particular 12 mystery test tubes experiment is to identify the 12 unknown solutions. As promised, I thought I would show you an example of a question that you would have been able to answer in the Intro Chem class. Again, you will probably have to be able to do that here, so I thought it would be a good idea to practice some of these precipitation reaction type questions. Here's the question. If 750 milliliters of 4 times 10 to the negative 3 molar cerium nitrate is added to 300 milliliters of 2 times 10 to the negative 2 molar potassium iodate, will a precipitate form? Remember, PPT is shorthand for precipitate. And the KSP of cerium iodate is 1.9 times 10 to the negative 10. In other words, if we find that the concentration of the ions is greater than 1.9 times 10 to the negative 10, then a precipitate will form. If it's less, then no precipitate will form. So to solve these kinds of questions, remember what you need to do. You need to write a KSP expression for those ions that have the potential of forming. And I forgot the 3 out here, so I apologize, which is going to clearly change the balanced equation. So cerium is a +3, and IO3 -1, and there's 3 of them. Those are the products. Now, the KSP expression is cerium times IO3 -1 to the 3rd power. Now, the value we get here, which your book will call Q, if Q is greater than the KSP, remember you're going to get a precipitate. If Q is less than the KSP, then no precipitate. And if Q equals the KSP, then you're at equilibrium, which they didn't talk about. But in this case, we're trying to figure out if a precipitate forms. So that means we're going to plug in the numbers for cerium and iodate, cubing iodate, and we're going to see how it compares to the KSP value of 1.9 times 10 to the negative 10. I tend to write it like this. I say, does it equal it? My guess is it's not going to, so we're going to see if it's larger or smaller. Now, it might be, at first glance, pretty easy to plug in this number in for cerium and this number in for iodate, because cerium nitrate, as you can see, moving it over here, cerium nitrate, when it forms ions, it's going to be cerium and 3 nitrates. And we're just interested in cerium. So you would think that the concentration of the cerium ion is the same as 4 times 10 to the negative 3. But remember, we are mixing. So we have to calculate the molarity of cerium once mixed. I tend to use MV equals MV, meaning that with 750 milliliters of the 4 times 10 to the negative 3 molar, that's the concentration of the molarity there. But what is it when it's 1,050 milliliters? What is the molarity at that point? And I got that number by adding 750 and 300. So when I calculate that, I actually got 2.86 times 10 to the negative 3. So that's the concentration of cerium. I would do the exact thing for iodate. This time I would say 300 times 2 times 10 to the negative 2 equals 1050 m. I would solve, and when I did, I got 5.71 times 10 to the negative 3. Don't forget to bring that 3 down, in this case the cube, because that's going to change the value of Q. When we work it all out, I got 5.32 times 10 to the negative 10. And we're going to compare that to 1.9 times 10 to the negative 10. And we can see the value I got is not equal to, it's greater than. So in this case, Q is greater than the KSP, so precipitate forms. That's the kind of question you are more than likely to be asked about, does a precipitation occur? Remember, however, as part of the 12th mystery test tube lab, your focus will be on producing a precipitate for identification purposes only.